As of today, anyone is able to use satellites to build their connected solution. You only need about $100 and a few hours of work to build your first prototype. And I'm going to show you. My name is Lawrence. Welcome to Show Don't Tell. Today we're turning a generic IoT device containing GPS and a temperature sensor into a satellite-enabled solution. Why do you want this? Well, think about trucks driving down very remote places, or big offshore projects with wind turbines, or maybe these mega farms in Australia that contain a lot of cattle. These devices don't operate in areas where there's public coverage. So you want satellites or non-terrestrial networks to help out to keep your devices connected. Lawrence here again. In this episode, we're going to take a device with a cellular module, connect it to a satellite, and send UDP data over narrowband IoT to a cloud server for storage, visualization, and processing. Let's get started. Start off by going to the Monogoto hub, create a new account or login, and click Order SIM. Head over to Satellite IoT Kit and order your IoT kit for $100. Click Next and get the package in your mail within a couple of days. So what's in the box? We have a device containing a cellular module that supports the 3GPP release 17. We have an antenna, we got a cable, and we get a Monogoto SIM. Then take the cable and connect it to the right ports. So normally you would then insert the plastic SIM, but because I'm using the Murata Type 1SC module, it contains an integrated SIM. So I'm using the eSIM instead of the plastic one. When a device is connected to your computer using the USB cable, we can open up a serial connection to directly configure the module using a T command. Using my terminal, I want to see what serial port the device is connected to. Then I can use a program like Minicom to connect to this serial port. Sometimes for this specific module, I need to press one of these three buttons, and only then I can start sending AT commands. Then I get the response OK. If I request ATI, then I get some device information. If this demo goes somewhat fast, don't worry, because we've written down everything. Head over to our docs, NTN satellite networks, NTN certified devices, certified modules, and select the module you're using from the list. Next, let's head outside because we need a clear view of the sky to connect with satellite. We managed to find a place with a clear view of the sky. Have a look. Now we continue configuring the module, allowing the device to connect to satellites. So I'm firing a couple of AT commands. This might go quite fast, but have a look at our documentation for detailed instructions on how this works and what specific commands you need to send. There we go. So this final AT command instructs the module to start searching for a GPS signal. We need to wait for the module to get a GPS fix before we can continue connect the device to a satellite. So let's give it some time. Any moment now. Should be almost there. It took a minute or so, but now the device has a GPS fix, as you can see in my screen. Great news, we can continue searching for a satellite connection. This again might take some time, so let's get back to it in a couple of seconds. We're using the satellites from Skylo. You will see that later in the Monogoto hub. Come on, buddy. It took 3-4 minutes in total, but the device is connected, and we can see that by this response. CREC is 5, and it means that the device is roaming. And in this particular case, it's roaming over Skylo's satellite network. So now things get really excited because the next step is that we start sending data using UDP to a UDP cloud server over narrowband IoT that goes via these satellites. Let's go. To validate that the device is connected, I looked up my device in the Monogoto hub Here we can see that it's connected to Skylo's NTN network. Some data already has been sent to establish this connection. And you can also find the device logs here. Next up, sending data. You can set up a UDP server yourself, or rather, use something that's already available. For example, UBDots. So you can sign up for a free developer account, and once you're logged in, it looks something like this, which is not too excited just yet. So let's start sending UDP data and create a device on the UBDots platform. So we check the UBDots documentation, and they explain that a UDP package needs to be formatted in such a way. So if we fill this out, it comes down to a message that looks something like this. User agent IoT kit, we're posting the message. This is the token that I partly hidden. Then we call the device the IoT device, and we fake temperature data of 20.6 degrees. Now here's an important thing. You cannot send text over satellite, so you need to convert those characters to hexadecimal numbers. So there are different tools for that, for example, rapid tables. The next step is sending this message over satellite to the UBDots platform. To do so, we first need to open up the UDP ports. We are activating that specific port. And once the port is activated, we can start sending data. And there's one final thing that you need to do before sending data. You need to count the exact number of bytes that you're sending. So you can do this by hand, but rather use a tool like ChatGPT and simply let them calculate it for you. So we send this UDP packet. Now we go back to the UBDots platform. We click refresh, and boom, a new message arrived and a new device was created. And then we look here and we can find the value 20.6, which defines the current temperature. Okay, really excited. Well, let's do this one more time, but now have a slightly different value. Going back to Minicom, sending a new message. We return to UBDots. We click refresh, and instead of 20.6, we now see 20.8. And if you click on the variable, then you can find two different values that have been sent. This is really exciting stuff. How often can you connect directly with satellites just using a few simple tricks and one of these cheap devices? Let's recap. We took this device outside, we waited to get a GPS fix, then we connected the device to Skylo's satellite, we defined a UDP packet, we sent it to UBDots, and we analyzed and monitored the data within the UBDots platform. Everything came together. Even the sun is now coming through. What a day. And the good thing is, you can do this. So I invite all of you to try this out yourself. Go to the Monogoto hub, register or log in, order this NTN kit, and within a couple of days, you can experience satellite connectivity yourself. That concludes the show don't tell about non-terrestrial networks. Thank you so much for watching. My name is Lawrence, and I hope to see you again in one of our next episodes. In the meantime, have a look at our website, order this kit, subscribe to our channel, and don't hesitate to reach out to me directly if you have any questions or need support. Good luck trying this out yourself.